In this video, we're going to be continuing with the topic of work, energy, and power. Let's take a look at this question. The diagram below shows a boy skateboarding on a ramp which is inclined at 20 degrees to the horizontal. A constant frictional force of 50 newtons acts on the skateboard as it moves from P to Q. Consider the boy and the skateboard as a single unit of mass 60 kilograms. Ignore the effects of air friction. Question 5.1. Draw a labeled free body diagram showing all the forces acting on the boy skateboard unit while moving down the ramp from P to Q. Okay, so as this boy moves down, there's going to be a force of gravity that's pointing down. Remember, do not show the components. There's going to be a normal force acting in this direction, and there's going to be friction. So that's our answer. 3 marks, 3 forces. 5.2. Points P and Q on the ramp are 25 meters apart. The skateboarder passes point P at a speed VI and passes point Q at a speed 15 meters per second. Ignore rotational effects due to the wheels. State work energy theorem. You have that, I'm not going to do that. 5.3. Use energy principles to calculate the speed VI of the skateboard at point P. Now, energy principles means use work energy theorem, but there are other equations that you could use. For example, you could use WNC equals delta EP plus delta EK. That's one option. You could use W net is equal to delta EK. That's also an option. You could also say WC is equal to minus delta EP, though we wouldn't use this one necessarily in this case because we want speed and EP has no speed in it. So we have an option. You could either use this one or this one. No matter which one you choose, as long as you do the calculations correctly, you will still get the same final answer. I will choose this one for this example. Okay, now let's consider W net. What's W net going to be? Remember, there are 2 forces that are actually in play here. If we have to just sketch out the forces, there's going to be a frictional force that's slowing down the skateboarder, and there's going to be the force of gravity parallel that's pulling the skateboarder down. The normal force and the perpendicular are acting 90 degrees and 270 degrees, and so they're not going to do anything. So if we wanted to work out W net will be F net times delta X times cos theta. Okay, and that's going to equal delta EK. Now we can do all of this in one step, but for the purpose of this example, I think let's break it up so it's a bit more easier to understand. So the work done by friction, that's going to be friction times delta X times cos theta. Friction was 50, delta X is 25, and it's going to be cos of 180 degrees. Now, why are we doing this? Why are we using 180 degrees? Because remember, the skateboard is moving down and friction is acting 180 degrees away from it. So 50 times minus 25, that's minus 1250 joules. Then FG parallel, let's work that out first. FG parallel is equal to mg sine theta. So 60 times 9,8 times sine of 20 degrees. 60 times 9,8 times sine of 20 degrees is 201,11 newtons. Now we need to work out the work done by this force. So the work done by FG parallel is equal to FG parallel times delta X times cos theta. So FG parallel we worked out as 201,11 multiplied by 25, and this is going to be cos of 0 because FG parallel points down the slope and the delta x is down the slope. So that's going to be multiplied by 25. This will give us an answer of 5027,696 joules. So if you want W net is going to equal 5027,696 minus 1250, and that's equal to 3777,696 joules. So that's our W net, and it's equal to delta EK. So we can go to our formula and we can say W net equals delta EK. We worked out W net, 3777,696 equals delta EK just means half m and then Vf squared minus Vi squared. That's delta EK. So it's going to be half of 60. Vf, so the velocity at Q was 15. So 15 squared minus Vi squared. We don't know what Vi is. So 3777,696 equals, now we can open up that bracket, so that t times 15 squared, that gives me 6750 minus 30 Vi squared. Now we can solve for Vi. So 3777,696 minus 6750 divided by negative 30 square root. The answer for Vi is 9,95 meters per second. So the velocity here is 9,95. The velocity at P is 9,95 meters per second. As I said before, you can do all of this in one step, in a few lines. I've broken it up here just so you know where the calculations come from and why we're doing them. But you can do them in one step, or actually 1 or 2 lines, and it will come to the same thing. Okay, question 5.4. Calculate the average power dissipated by the skateboarder to overcome friction between P and Q. So they ask you for average power, and the formula for average power, P average. So question 5.4 is equal to F multiplied by V average. Now, what force are they talking about? What force are we going to substitute here? If we read the question carefully, they want to know to overcome friction. So it's the frictional force. The frictional force was 50. And then multiplied by V average, we want to know what is the average velocity between P and Q. We're just going to add them and divide by 2. So 15 plus 9,95 divided by 2. And that gives us an answer of, let's just check, 50 and 15 plus 623.84 watts. That's our answer. And that's it for the section, for this specific question actually. If there's something specific you'd like me to do, let me know in the comment section below. If you enjoyed this video, please consider leaving a like, subscribing, sharing. I'll see you in the next one. Bye.